All right. So first we're going to do chapter 3 revision. So this is revision on quadratics. All right, quadratics. Okay, Daniel, if you're listening to this recording, you can choose to listen to it at 2 times speed if there's anything that you already know. And then I'll send a separate recording for your school content afterwards. Okay, so chapter 3 revision, quadratics. The first thing I want to revise with you guys is the difference of perfect squares. Difference of perfect squares. Does anyone remember the formula for this?
Yes.
Amani?
It's the brackets a plus b brackets again squared, and then it'll turn into the brackets a plus b brackets another bracket a plus b. That thing?
No.
Oh,
Difference means minus of perfect squares.
So a brackets a minus b.
That's wrong.
So a squared minus b squared
It is a squared minus b squared. Yes.
equals brackets a plus b
Did I do completely?
and brackets a minus b.
Yes, this is the idea of difference of perfect squares. Okay. So the difference is a subtraction, and these two are perfect squares. Any question?
No.
No.
What did I say?
You said a plus b everything squared, which is a different one. That's expansion of a perfect square.
Completely different thing.
All right. So that's expansion of sum or of perfect squares. Put it that way.
So which one's the one for I can't remember.
The complete the square requires on the expansion of perfect square. So the expansion of perfect square, there are two formulas. There's the a plus b everything squared, and then the a minus b. Correct. Amani, what's the plus one then when you expand this? Don't use the two brackets. Yeah, you're not allowed to do the two brackets and rainbow method. No, you have to remember. You have to remember the final answer straight away.
Oh.
Do you remember? It's a formula.
A formula?
Yep.
A squared
Yep.
minus plus
Nope.
b squared
No.
2ab
2ab.
plus b
plus
squared.
b.
Yes, that's right. And then the minus version is
A squared plus 2.
nope.
A minus 2ab plus
plus
b squared.
Yes, that's right. These two you have to remember. Okay? And then the difference of perfect square you also have to remember. Right?
Mr. Croucher was hating on math the other day.
I hate Mr.
He said he's because we were asking
Factorize this one.
This thing.
A squared minus 9.
Hold on. Wait, what are we?
A squared minus 2a like 18a.
A minus
No.
2a squared.
A plus 9.
A minus 9, A plus 9 is
Oh,
wrong,
wait.
but you got the right idea. But it's not 9.
Oh, 3.
3, yes. It's a minus 3, a plus 3. Why? Because this is a squared minus 3 squared. Remember, you got to convert this number into a perfect square before you can use the formula. Okay? Alright, let's try another one. What's x minus, Louise, what's x minus 16? X squared minus 16. Factorize for me.
Okay, x minus 4, x plus 4.
Yes, that's right. Now, let's try a slightly harder one. What's 4x squared minus 9?
4 at the front. No, 2 at the front, right? There you go.
Sorry, what?
Can you turn this into difference of
2x
perfect square?
minus
Yeah.
3.
Correct.
2x plus 3.
Very good,
I was
Ashby.
so close. Oh my god.
Amani, any question?
No.
No? Yeah, 4x squared is just 2x everything squared. How about this one then? How about 3x squared minus 27? How do we use difference of perfect square on this one?
You take it out, you take it out,
You take out the 3, yes.
3 and x
plus
minus
x plus
We already had a plus here.
what is the thing? Oh, sorry,
x minus 9 or something.
Yes, it's x squared minus 9. You take out the 3 first, okay? And then you inside it will be the difference of perfect square. So factorize that, what do you get?
x
So 3 first, right? The 3 factor is still there, and then?
Oh my god, I can't. 3x. What? Wait. 3x minus 3. And then another one, 3x plus 3. X plus 3.
It's just x plus 3. Okay, any question here? No? So these are the factorizing using difference of perfect squares. Okay, very important. These are the questions that you will see in your revision booklet that you guys have to do again for the fourth time. But this time, hopefully,
Wait, is this
Wait, is it like the exact same as like the last question?
exact same. Yes, that's why you have to go for speed.
Really?
This time, like if you can't do it, shame on you. I'm kidding. Make sure you practice until you can do it all.
Actually, I
Okay?
don't even
If
take
you
that
get one
shame
wrong,
on
you
you
have
for
to go
offense
outside.
anymore.
You have to
Can you
go.
like
to do your
shut
math on
up
the
with
steps
going
outside.
outside? How
You
about
have,
you?
no,
go
you have to do
outside?
your math on the steps outside.
Wait, don't.
How about you go outside? Hey, do you want my jacket? Are you?
Are you cold?
Okay. All right, guys. Continuing. Do you guys remember how to factorize? Okay. Now this actually the next part is important. This is the based on the expansion of perfect square. Expansion of perfect square. Based on the two formulas that we got up here. Okay, is these two formulas here. Can you factorize something like this straight away? X squared plus 2x plus 1. Can you factorize this straight away?
Yes, we can.
Yeah. What is it?
X,
Not the ACB table, if that's what you're wondering.
you do your perfect square thing.
Correct. So this one would be a. Is this a perfect square?
Well, no.
No.
It is a perfect square.
What? Okay, well, x
It's the opposite day. I said
x
yes.
plus x plus 1.
X plus 1, everything squared.
Yes.
Why? Because if you use the expansion of perfect square, you get x squared plus 2 times x times 1, which is simply just 2x, right? And then plus 1 squared, which is 1. Does it make sense?
Oh.
Yeah, 2 times x times 1 and then plus 1 squared.
Wait, can I write that
okay.
down, please?
Yes.
Sorry for doing it.
Okay, so you guys need to be able to recognize like some basic expansion of perfect square straight away. And those basic ones are these ones here. X plus 2 squared, x plus 3 squared, and then x minus 1 everything squared, x minus 2 everything squared, or maybe not this one. So x minus 1 everything squared, and then x minus 2 everything squared. You have to be able to recognize the like be able to expand these ones straight away. Okay, they're not hard if you know how to apply the formula. All right, first one, Luis. What's x plus 2 everything squared?
X squared plus 2x 2
Yep,
plus 2 squared.
yep, that's right. And give me the simplified version. I'll write it on the left here. You have to recognize these
X
forms.
squared plus 4x plus 4.
Correct. You see, x squared plus 4x plus 4. You see, this is very common in when you're doing like completing the square as well. All right, Ashwin, what's x minus 1 everything squared? Explain that.
X squared plus 2.
Plus?
Sorry, minus.
Yep, because of the minus here.
2x negative 1.
No, just 1.
Just 1.
Because the formula already account for the negative.
Oh, okay.
Mm-hmm.
Plus 1 squared.
Yep, and then simplified version.
X squared minus 2x plus 1.
That's right. See, very, very familiar, right? The only difference is the plus 2x versus the minus 2x. All right, Amani, are you confident to give me the simplified version straight away? Or do you want to try the long version first?
I can try the simplified.
Okay, all right, try the simplified version. What is it? What's x minus 2 everything squared?
X squared minus 4x plus 4.
Yes, perfect. Very good.
You ate that.
Okay, now let's see. Can anyone tell me the simplified version of these two here?
Wow.
X squared plus x squared plus 6x plus 9.
Yeah, plus 6x plus 9. And the other one would just be?
X squared
just
minus
like
6x
with the
plus
minus.
9.
That's
Why
right.
is it 6?
Just like
Because 2
with
times
9.
x times 3.
Wait, no.
So you do 2 times 3
no,
first?
It'll be the 2, yeah.
Yeah,
High five.
it's
So,
just
like, you go
flip that
backwards, I
around.
go backwards.
Okay, does it make sense, guys?
Yeah.
All right. So if I were to give you guys completing the square, now let's do a bit of revision on completing
I'm getting finger surgery.
the square. Okay. So when you guys are completing the square, all right, if you get something like this, let's say x squared plus 2x minus 1. All right, what are we missing in order to complete the square?
We're missing
What are we missing to complete the square?
The squares.
What?
we're missing a drawing of a square.
Remember, the
Plus 1.
yes, you're missing the plus 1. That's right. So we need to add the plus 1 in to complete the square, right? And how do we keep it the same? When you add plus 1, you also
Add
Minus
another
one, minus one.
minus 1, and then you put back the original minus 1 here.
yeah.
Remember this?
Yeah,
Yes.
I remember doing
Yeah.
that.
And then what's the, and then you group the first 3 terms together, that turns into?
X plus 1 squared.
Yes, that's
minus
right. Any
2
question?
No.
Minus 2. Yeah,
Oh, this
that's
is where
a,
the numbers become the little ghosty things.
Plus, wait.
And then
Minus
if you
1 plus
square
minus
root it?
root 2.
yes, but we're stopping here. We're stopping here. We're not solving for x, we're just stopping here. This is the completed square version. Does it make sense?
Yeah.
Yeah?
Oh wait, hold on.
Right.
I just want to write this down quickly.
Yeah, okay. So this is very, very important. Yeah, you guys need to be able to do
I
this.
think
Yeah,
Louise
I'm
needs to be
writing
sent
down
out
as well.
today.
I don't need to be sent out.
She's
I'm perfectly
misbehaving
fine where I
a little.
am.
Okay, alright. Now let's see if you guys can do this one here. X squared plus 6x minus 4. What are we missing?
Brackets 6 plus 3 squared.
What do you mean 6 plus 3 everything? That sounds a bit strange to me.
Sorry, what?
No, it's brackets x squared plus 6x plus 4.
No,
Plus
2?
3.
not 3.
Plus.
5.
It's the square of half of that number.
3.
3. No.
3 squared.
Oh.
Okay, not just 3. It's 3 squared.
What?
Does it make sense?
Squared minus 3.
Okay, because if you use a formula, it has to look something like this, right? 2 times 3 times x, and then this is why it's 3 squared. Remember, it's 2ab, but then this one is a b squared one, right? So that's why you need to have that number and then you square it. Okay, that's basically the rule. Okay, you have the number and square it, and then you can start subtracting that. All right, and group them together, and then minus 4 here. What's the completed square, Ashby?
The completed square is x plus 3 squared.
And then?
That is, that's 9. 9, take that is 13. Negative 13.
Negative 13. Very good. Any
That's
question?
what I was doing.
Good. Okay. Any question here, guys?
Mate, get
No.
autism.
Guys.
Sorry.
The next one would be a quite complicated one. It's x squared plus 3x minus 4. Now, this is not an even number. The coefficient of x is an odd number. And remember, what's the rule? What did I say was the rule? You will need to add a term that is half of the coefficient of x, and then square it. Does it make sense?
Yep.
Yeah? Because half of it. But then you also need to subtract the exact same thing in order to balance it out. And then you add the minus 4. Okay, now does it make more sense? This is the harder one, but does it make sense now?
Yeah.
Yep.
Yeah? Because we spent weeks on these topics, and that's how it can make sense now. Okay, make sure you go back and practice it otherwise. Okay, what's in the brackets, Amani? What's the completed square?
Sorry.
X plus brackets 3/2.
Yes, or you don't need the brackets, it's just 3/2.
Yeah.
Very good, alright, and then this one would turn into, anyone?
9
9
over
over
4.
2.
9 over 4, not over 2, you have to square both top and bottom.
4 brackets.
And then how do we subtract 4 from this? Anyone?
Make that into a bracket and then make it the same denominator.
Yes, whatever you guys are saying. So 4 over 1 and then same denominator, which is
4.
16 over 4. Okay, wait, pause. Amani, what's the answer to this part there? Minus what? Are you adding them or are you subtracting them?
You're adding them?
Yes, you're adding them, which is?
15 over 8.
No. When you're adding a subtracting fraction.
No,
So the answer is 25 over 4. Okay, so that's a completed square. Any question?
Nope.
No? Manny, make sure you practice this, please.
No.
Okay, fraction operations are quite
but
common.
no.
All right, now let's go to the ACB table. Okay, this is the ACB table. You guys remember this?
Yeah.
Okay, so how do you factorize something like?
Okay, so my teacher did not know ACB table, right? And she was proving me wrong.
Who?
Get it? Miss Wu. Miss
Oh.
Wu. Miss Wu was like, oh, I don't know.
Roger has the issue where he'll like start to.
What's the ACB table here?
Don't
Explain.
talk about Croucher.
He
Bad
won't.
about
He
it.
won't explain for
ACB table. What is the value for AC here?
Negative
-5
and
and
B is
+3.
-5, and then that's 3.
Okay, so what are the factors of negative 5?
Negative.
Oh, let me see this.
What?
5 and 1. Wait, you can't like. There's no.
Sorry, it should be negative 10. My bad.
Yeah.
Yeah, -10.
Yeah.
What happens in the
five-
instance
five
that
and
you
two.
can't do the
Five
ACB
and
table?
5 and
We'll
negative
get to that in a
2.
second.
5 and
5 and
negative 2.
-2.
5 and negative 2? Yes,
No,
that's right.
Yes.
Okay, and what type of quadratic is this?
Monic.
Monic.
Monic, very good. Do your teachers tell you about monic and non-monic?
Yes, Mr. Croucher did.
No.
Good.
No.
No, not good. Anyway,
Yes.
so factorize it, that would be x plus 5 and x minus 2. Any question?
No.
No.
I love this side of quadratics.
Okay, and then when we have non-monic, okay, actually when we have something like this, 2x squared plus 6x minus 20, what do we do first?
Oh, you times
You
the 2.
negative 40.
Not
and
times
6.
No, you times
No.
the 2 and 20.
No,
What? Why?
Because-
Oh, you take the 2 out.
you take the 2 out, yes, because that's a common
take the two
factor.
Oh, and then you do the bracket.
2x.
Yep,
And then you add the numbers into the thing, yeah.
yeah, that's right. So when you factorize it, the 2 is outside of it, and then the rest, because this is the same as that one over here, right? So when you do the ACB, it will just be x plus 5 times x minus 2. That's it. So the only difference is it has the 2 at the front.
Wait,
Mhm.
it's like so when
Then what happens
like
to
it's
two?
like that and it equals 0, then we apply the non-factor law.
Correct. Yes. So let's say if this is equals to 0, equals to 0, equals to 0, then you say no factor law.
Oh, it's only if it has equal zeros and not.
Only when it
Oh,
has
okay.
equals to zeros, yeah. So this one will be 0 or x minus 2 equals to 0. Okay, so x equals to negative 5 or x equals to positive 2.
Where does the 2 go?
Because it's just a constant factor. You divide both sides by 2, you cancel that out.
So then do you have to put the 2 at the front, or can you just like leave the 2 out?
You need the 2 at the front until you use no factor law.
Okay.
Okay, so you have to keep the constant factor
So
at
you
the
kind
front
of just
until.
drop it without doing anything.
No, you can't just drop it. Yeah. Well, technically, if it's equals to 0, you can drop it. So what you are saying is that at this point, you can divide both sides by 2 like that, right? And then this 2 will be cancelled out. So technically, the next line, you can remove the 2 because you're saying you're dividing both sides by 2, and 0 divided by 2 is still 0.
Yeah.
Okay? So technically, this line here, you can get rid of the 2 at that line. But the previous line, you need the 2. Okay? All right? Now, for non-monic quadratics, what do we need to do? Yeah, what?
You need to times the like A and C.
Yeah, this times A and C. So let's say for
Oh, that's for non-monic. Because you know how I told you on top, I was like, oh, you have to times the.
yeah, that's for non-monic. That's right.
Okay.
That is for non-monic quadratic. So 2x squared plus 3x minus
6.
5.
Okay.
Whatever.
Okay. So I got this.
Negative 10.
I got
3.
this. Hey,
Mhm.
shh, it's my time to shine.
Okay, Ashrit.
AC.
Ashrit, try.
So 2 times negative 5, which is negative 10.
Mm-hmm.
And then plus 3. And then you have to find stuff that equals, so it's 5 and negative 2.
Yep, and then?
Yep. And then you go into that and you go 2x squared plus 5x
Yep.
minus 2x
Yep.
and then minus 5.
Yep.
And then you take out like... wait,
What do we
what
take
was
out?
that?
Take out the common factor.
Yeah, take out the
Which is? A bit
X.
tricky.
X.
Okay, x, and then?
So
2x
it's 2x
plus
and then
5.
plus
Okay.
5x. And then for the second one,
Minus
just take out 1. Minus
1.
1.
Minus 1.
Yeah.
Yeah, in order to get positive
That's
2x
5.
and then plus 5.
And then
Okay.
you do x,
X
minus
minus
1
1,
and then
2x
2x
plus 5.
plus 5.
Yep, very good.
You're trying to take my shine
I
away.
am.
Does it make sense, Amani?
Yeah.
You remember this? Yeah, the main idea in the non-monic quadratics is that the middle term, you have to split
it.
Yeah.
Yeah.
using the two numbers from the ACB table. Okay, cool. All right. So you guys still remember all of this? That's not bad. Okay. Next is graphing quadratics.
Yeah, I actually really struggled with graphing my quadratics. I just couldn't.
No, just go to
Okay.
math tutorials. I went with Douglas and she helped me so much.
There was something
every
intriguing. There was
time.
something this
Yeah, I'm going this week as well.
that I didn't
No, I
remember or know about.
Guys.
I don't think we did introducing this method.
Yeah, because
The one that you guys learned with me was the turning point form. Okay. 3F, I'll go through 3F. So this is 3D. Okay, the first one you guys see is 3D. That's the turning point form. 3F is the one after you learn completing the square.
This is 3D.
Actually, no, 3F you learn after completing the square, because in order to use the turning point form, you have to complete the square first. That's why they teach you this one first.
they
Right.
told us that. They told us that.
Yeah. What's the turning point form?
Y equals A brackets x minus h and
Plus
brackets
K.
squared
K.
plus k.
Yep, that's right. Actually no. Amani, what's A, H, and K?
There's no numbers.
Oh, actually, yeah. I think I haven't explained to you guys the meaning of these ones yet. Okay.
Oh wait,
Um,
no. It's like the negatives and the zeros and
A
stuff.
is the
Yeah.
dilation.
Yes.
H
Like,
is
tells
H
you
is
whether it's going up or
H is
down.
left or right, and K is
and
vertical.
Where's the A
Very good,
tells
that's
you
right.
whether it concaves up or down. That's what Dougie told me.
Horizontal translation is
X minus
Right,
H.
this maybe.
Yep. And then K is the vertical.
X plus 2x squared plus k.
Yeah. Okay. The K, basically the K is the vertical translation. What is H comma K?
Turning point.
Is the turning point. Yes, that's right. Okay, good. So turning point. So for example, if I have y is equals to
Oh, I don't understand the domain.
okay, I'll get that in a
Range.
second.
I'm not that is.
Okay, range and domain. All right. So let's say if I have the equation y is equals to 2x minus 1 and then squared plus 3.
Yeah, I didn't
What's
know
the I'll get
That's
to that. I'll
part
get
of
to
the
that.
textbook though.
It is part of the textbook. That's right. I'll get to it now.
Mrs. Hamilton's literally.
All right. I don't
She's
care about
my
your teachers.
teacher.
Shh, guys. In this equation, what in order to work out the graph of this equation, what do we do first?
Find the x. No, find y.
You find A, H, and K.
Yeah.
What's A, H, and K?
H 1.
Yep.
K 3.
Okay. And then based on this, what can we find next?
You can find the turning point.
The turning point. That's right. Which is
1 3
3.
negative 1. No.
positive 1. X minus A. Right. Okay. So it's turning point just 1 and 3, and then we can find the
Y-intercept.
Yep. That's right. Y-intercept. How?
3.
X equals 0.
Yep. You sub X equals
What's
to
the
0.
one
That's right.
where there was one they did with us,
3.
and I don't know if
3.
it's just them writing it weirdly.
Yeah. Don't worry. I'll get to all of them in a few seconds. Okay. So guys, focus. Just
Are you doing
step
the
by
3F
step.
one?
Hmm?
Are you doing
This is
3F?
3D. Yes, I will get there. Okay, calm down. I'm doing it one by one. So whatever question you guys have, hold it there first. Right, I'll go through everything, and by the end, if you guys still have questions, then I'll answer those ones.
Okay.
So the x-intercept, the y-intercept is when you sub x equals to 0, then you get y equals to 2 times 0 minus 1 everything squared, and then plus 3. Make sense?
Yep.
Yep. 0 minus 1 squared is just minus 1 squared is that it will just be 1, and then that will just be 2 plus 3, which is 5. So the y-intercept is 5. Okay. Then we solve for the x-intercept. How?
Y equals 0.
Sub y equals to 0. Very good. Sub y equals to 0. So I get 0 equals to 2 times this thing squared plus 3. How do I solve this?
You move things.
3.
You move
negative
things.
3 equals 2.
Correct. You move the 3 over first. So negative 3 equals to 2 times x minus 1 squared. What can we tell from this?
Negative.
When you square something and times it by a positive number, can you get a negative number?
No.
No, which means
That there isn't one. There is
No
no.
solution.
There aren't any.
no solution. Yes. So no x-intercepts. Okay. All right. So based on all this information here,
The moment it becomes a negative on that side.
then there's no x-intercept. Yeah.
Okay.
Because when you square a number, you always get positive. You can't get a negative. Which means we can sketch it right now. So turning point 1, 3. So x is 1, y is 3. Put the turning point in here. Actually, I'll change the scale up a little bit. Let's say 1 is here and then 3 is here. Right? Put 1, 3. What's the y-intercept? 5.
5.
All right, so let's go 2, 1, and then 4, 5. 5 is here. So that's the y-intercept. So it has to cross through the y-intercept and has this one as a turning point and then curve up again. Okay, does that make sense?
Yep.
Draw the 2 arrows there. All right, so this is a graph of a parabola that does not have x-intercepts. All right, I'll show you a version with x-intercepts. So another version with x-intercept would be, let's say, sketch. All right, y is equals to negative x plus 2 and then plus 3. Let's see if I can square it and then plus 4, for example. All right, so what's a h and k?
A is negative 1, negative 2, 4.
Yep, negative 2 and positive 4. Good, because this is minus h. All right, so what's the turning point?
Negative 2, 4.
Negative 2. For any question here? No. Ashpreet? No. Okay, so moving on, can you guys find me the y-intercept and the x-intercept?
Yes, we can.
Okay, all right, work it out on paper and tell me what the answer is.
3.
Okay.
Because it's negative 4 plus 4.
Oh, negative 4 equals negative 4, which is
Oh.
0.
Yeah, and that would be negative of 4 and then plus 4, and that would be equals to 0. So the y-intercept is 0. X-intercepts, what are the two x-intercepts?
Yay!
X-intercept is 0 and negative 4. Here, I'll show you the workings. 0 equals to negative of this thing, and then plus 4. Note that when you see this expression, do you see that there are two terms? That's 1 and this is 1. Well, you guys see that? Ashpreet, the money. You see that? Which one do you want to move here to the other side? No, you move the negative term to the other side. Because when you move the negative term to the other side, yes, it turns into positive. So this positive x plus 2 squared equals 4, which means x plus 2 equals to plus minus square root of 4. Okay, so when you have squared, there are two answers, which means you get x plus 2 would be equals to positive 2 or x plus 2 equals to negative 2. And then when you move the 2 over, so then x would be 0 or x would be minus 4. Okay, all right, so let's sketch that. All right, let's sketch that. Is this a normal parabola?
Yeah.
No.
Oh.
It's not
it's concave down.
It's concave down. Yes, it's concave down. So the turning point is negative 2 and 4. So let's say y is 4, x is negative 2, and then we have the intercept to be negative 4 and 0. All right, so these are the two x-intercepts, and the y-intercept is also at 0, which is the origin, 0, 0. Right? So the turning point is negative 2 and 4, which is the top here, negative 2 and 4. Then you just need to draw past that one and then draw past this one here. That's it. This is the graph of a upside down or concave down parabola that has x-intercepts. Does it make sense?
Yep.
Yeah. You guys think you guys can do the graphing questions when this one comes up?
Yeah.
Yeah?
We already started graphing.
Yeah. Now, you guys will in the chapter 3D, you guys are given the turning point form. But what if they ask you to sketch something that is not in turning point form? Sketch y is equals to x squared. It's not a times x minus no. It's x squared plus plus 2x minus minus 3.
You can complete the square to make it into the thing.
Yes, you can complete the square. That's right. So complete the square for this one.
X plus 1. Wait, x plus 1 minus 3.
Yep. Plus 1 minus 1 minus 3. Any question here? No. Okay. Then these 3 will turn into what's the perfect version?
X plus 1
That's
squared minus 4.
That's right. Okay. And then the rest just follows. Okay. Once you've got this one, then yada yada yada. Turning point form. Okay. Sketching.
What
So you
type
guys can
of
do
sketch
sketching.
is this called?
This is turning point form sketching. Okay, so chapter 3E is about turning a standard. So this is the general formula, or like the expanded or general form. Okay, you need to turn something from a general form into the turning point form. Okay, this is the turning point form. So once you've got the turning point form, you already know what to do. Okay. All right. There are a few other things that you can. Chapter 3F is the one that's a little bit different. Okay.
Yeah, that's the one I was struggling with.
Yep. I'll go through chapter 3F now.
I haven't done that one.
I haven't
yet.
even started like chapter 3.
My class
yet.
hasn't done that.
Okay, don't worry. That's why I'm going through it now because it's actually part of the sheet here. You will have to do that. Alright, 3F and actually 3G. But I'll go through 3G in the second half after you guys have done some practice on 3F, 3A to
We
3F.
did H and I today.
Wait, I'm literally up to like.
H and I.
Yeah.
Alright, so chapter 3F is about graphing a. Oh, okay. I'll use the exact same equation as last time. So y is equals to x squared plus what was it? 2x minus 3, right? Okay, how do we graph this one but
Standard
not
form.
having to? Yeah, it's a standard form, but we don't use the complete the square method.
You do the minus b over 2a thing.
Correct. The key information is the axis of symmetry. Okay, so this is the most important one. The axis of symmetry, right? Symmetry formula is x is equals to minus b over 2a. Just gotta remember this. Okay, minus b over 2a. In this case, the axis of symmetry would be what? Axis of
-1.
Yep, symmetry is x is equals to minus of 2 over 2 times 1, which is minus 1. Okay, so that's the axis of symmetry. Now, remember the axis of symmetry is the idea that when you have a parabola, it will cut through the turning point, right? And then this line is the axis of symmetry. So how do we find the turning point from the axis of symmetry?
Wait, I have a question. Where did you get negative?
You sub it
no,
back into
sorry.
the equation.
Yes, that's right. Next would be you to find the turning point, and you find the turning point by
Putting it back into the equation.
yep, sub the value of the axis of symmetry, which is -1, right? Sub minus b over 2a into the original equation, into y.
Y equals -4.
Okay, and this would be x equals to negative b over 2a into that. So in this case, sub x equals -1 into the equation for y, then I would get y is equals to -1, everything squared, plus 2 times -1 minus 3. Then I would get -1 squared, which is 1, and then minus 2 minus 3, which is -4. Okay, so this is the y value when x is equals to -1, and that's the y value of the turning point.
Is this where you do the simultaneous equation?
No,
This is the one that you do that.
it's a different one.
It's this one here. I don't know what chapter this is.
Let's see.
I think it's
Momo.
No, it's not. That's not chapter 3. I don't think in chapter 3 you need to do the simultaneous equation. Not in chapter 3, I think. On top of my head. Alright, anyway guys, have a look. So this is how we find the turning point. At this point, we would get the turning point is equals to -1 and -4. What else do we need to find in order to sketch it?
The x and y.
That's right. Next would just be finding x and y intercepts. Okay? And how do you guys know how to find x and y intercepts, right?
yeah.
Okay, and y intercepts. How? Okay, can someone tell me what's the okay, our y intercept is sub x equals to 0. Now look at this equation here. What's the y intercept of this equation here? Can someone tell me?
-3.
-3. That's right. How did you know?
Because if y intercept is x equals 0, then it's just all gonna be 0 except.
Yep. This is 0. This is 0. So the only thing that's left when you stop x equals to 0 is -3. So in the standard form, right, the constant term is always the y-intercept.
Would you have to show working?
No. You can simply just go y-intercept equals -3. Done. You get the mark for it. I don't think they will request any extra stuff here. Okay. Or you can go y-intercept is when sub x equals to 0, and then you can just write y is equals to -3. Box it up. That's the y-intercept. Okay. Pretty standard. Now for the x-intercept, how do we find x-intercept in this equation here? What's the technique?
Define y-intercept.
Y.
X-intercept.
Y equals 0.
And then?
And then you just like solve it. You just do it.
You do the
pause.
0
What's the technique?
equals.
Ashpreet or Mani?
You can either do the TP x equals negative b over 2a, or 0 equals whatever the equation was.
You let 0 equals to whatever the equation was, and then what? How do you solve it?
For it?
Yeah, how do you solve for it? Is what I'm looking for. What's the key word here? Ashpreet? How do we solve for? Okay, you guys gotta stay on top of.
X squared minus 9. Then you'd move the x squared.
No.
Okay, I don't know.
So 0 equals to
Simplify.
x squared plus what was it? 2x minus 3, right? 2x minus 3. How do we solve this?
It's a quadratic.
Yes.
Mono. ACB table.
ACB table is the keyword I'm looking for.
Oh.
Does it make sense?
Yeah.
When you see the standard form, to solve for it is the ACB table. Yeah? So this is the A. So solve for x. Solve via ACB table. Okay? Any question?
No.
No. Ashpreet, am I losing you?
No, you're not losing me. I'm right here.
Okay, better be right here. Amani, any question?
No.
No? So this is the main idea for 3F, okay? There are only 3 steps. I'll go through that again. First, axis of symmetry, x equals to negative b over 2a, okay? This is the main step, axis of symmetry, okay? Once you've got that, you can find the turning point by substituting the exact value into the original equation. Any question here?
No.
No?
Can we
Ashpreet?
do a full
No.
equation?
Sorry?
Can we do a full actual working out thing?
Yeah, sure, okay. So, okay, I'll show you
With all the things in it.
without all the other things in it. Okay, now,
Like up to graphing.
yeah,
Oh, you look so scary.
okay,
That's like Momo.
that's fine. Let's try this.
Do it. Come on. Don't try to do it.
All right, guys, sketch y is equals to x squared plus x minus 12.
You're haunting.
You're holding.
All right, guys, focus, please. X squared plus x minus 12, then the symmetry. Okay, so first axis of symmetry, okay, would be minus, so x is equals to minus b over 2a, and minus b is 1, so minus b is minus 1 over 2a, a is 1, so that's 2 times 1, which is negative 1 over 2. So then the turning point, substitute x is equals to negative 1 over 2 into the equation for y. Okay, then we get y is equals to negative 1 over 2, everything squared, plus negative 1 over 2, and then minus 12. So this one is a little bit harder because this one is a fraction. We're working with fractions. So that would be 1 over 4 minus 1 over 2, and then minus 12. Any question here?
No.
Yeah, it's got to solve that. So 1 over 4, make everything over 4, minus 2 over 4, minus 48 over 4. Okay, so minus 2 minus 48, I'll work out these ones first. That's negative 50, and then plus 1 is negative 49 over 4. Okay, so we've got the turning point. Y value is negative 49 over 4. So now let's write it down. Turning point is x is negative 1/2, and then the y value is negative 49 over 4. What's roughly 49 over 4?
48, 12.
Negative 12 point?
Point
Five.
like 1.
5.
0.25,
Oh.
because the remainder is 1. Okay, 49 divided by 4 is 12, remainder 1, and then 1 divided by 4 is 0.25.
Yes.
Yeah, that makes sense? That's why it's negative 12.25. So I can technically write negative 12.25 here. Alright, and then what else do we need to find? We need to find the...
The x-intercept and
Yep.
y-intercept.
So what's the y-intercept?
The y-intercept is negative 12.
X equals 0.
Which is negative 12. So remember, the constant term is just the y-intercept in the standard form. Okay, so y-intercept is negative 12, and then x-intercept, right? You need to set y equals to 0. So 0 equals to x squared plus x minus 12. What's the technique here?
ACB table.
Correct.
12 and 1.
Negative 12 and positive 1.
Negative 12 positive 1.
No.
What?
Factors of negative 12 add up to
4
1.
and 3.
4 and
Negative 3.
and negative 3. That's right. Is this a modic quadratics?
Yes.
Negative
Yep.
4 and 3.
Yep. But I'll write it in this form first, and then you can write no factor law. If you can do this equals to 0 and solve straight away, that's okay
X
too.
equals negative 4, x equals 3.
That's right. Okay. So we've got these ones. We've got the y-intercepts, and then we can sketch it. Okay. Let's put in the y-intercept first, which is negative 12. These are all negative numbers. So let's say negative 12 is here. Okay, that's the y-intercept. And then x-intercepts are negative 4 or 3. So 1, 2, 3, negative 1, negative 2, negative 3, negative 4. So negative 4 is here, positive 3 is here, and the axis, the turning point is negative 1/2, which is like around here. Okay, and then the y coordinate is negative 12.25, which is a little bit below 12. Okay, so this is negative 1/2, and then negative 49/4. Right, which is that point there. Now let's sketch it. It has to go through these one, and then it has to go through this one here. That's it. Okay, make sense? Okay, and then you can also draw down the axis of symmetry, which is x is equals to negative 1/2. That's the axis of symmetry equation. Okay, that's it. Make sense? So that's 3A to 3F. Now it's your turn to get started. Right, I'll pause the recording for the first half now.